In this video, I'll show you how to do probability calculations for an example to do with the normal distribution. And in the video, I'll show you how to use your graphics calculator, in this case the Casio FX 9860. So let's look at the example. The scores for a season in a football tipping competition are normally distributed with a mean of 120 and a standard deviation of 16. And then there are three parts to the question here. We don't need to read them on this page. Let's move to the next page and we'll deal with the first part. The first part says, find the probability that a person in the competition, chosen at random, scored more than 140. In other words, they were better than average. But what's the probability they scored more than 140? Well, it's a good idea in these problems to draw a diagram. So if we draw a normal distribution of this, first of all thinking of that the mean is 120, represented by the Greek symbol mu, mu is 120, and the standard deviation represented by Greek letter sigma is 16. Drawing our picture, here's the mean of 120. This line here is marking one standard deviation right of the mean. In other words, that would be 136. So 140 is a little bit beyond 136. And the question says, find the probability that a person scored more than 140. In other words, it's to the right of 140. That's the area that's been shaded. So here's how we use our graphics calculator. First of all, we must get it into statistics mode or stat mode. So we move the cursor over to stat, go into statistics mode, and now we're dealing with the normal distribution. So we use this one, DIST, standing for distribution. Here's normal, NORM, standing for normal distribution. Now, the option we choose here is NCD, normal distribution, cumulative distribution. It's going to be adding up probabilities, and it's therefore NCD. So we go into that one. And now, we're not using data in a list. We're using data given as variables. So this is the one we want. It's already been chosen. Then we move down and we put in the lower bound for scores that are allowed here, 140. Enter it. The upper bound, well, there's no upper bound. There might be a certain number of highest possible scores that you could get if you got everyone right, but in all of these examples, we just put in the highest number we can that our calculator will accept, which is e to the 99. So we do x 99, the biggest number that the calculator can handle, as our biggest. Enter it. Now we need to put in the standard deviation, 16. Then we put in the mean, which is 120. Enter it. And then we'll hit XE again and we'll have our answer. Here it is, the probability that person chosen at random scored more than 140 would be 0.1056, etc., etc. Rounded off to three significant figures would be 0.105. In fact, 0.106, of course, rounding up the figure afterwards. In a sentence, the probability that a person in the competition scored more than 140 is 0.106. Okay, what about the second part of the question? Find the percentage of tipsters who scored between 100 and 120. Again, we draw a picture. First of all, writing down though our mean and standard deviation. Here's our picture this time. 120 is the mean. Now 100 is to the left, so we're coming back, and this point here, one standard deviation from the mean to the left would be 104. So 100 is just a little bit less than 104. That's where I've marked it. Shading the area, scores can be between 100 and 120. Now reaching for our graphics calculator, we just need to exit to go back. And we don't need to go back any further than that because we just need to change our lower and upper values. The lower value now is 100. The upper value is 120. Same standard deviation, same mean, nothing more to change hit XE and we see the probability is 0.3943, etc. Round off to 3 significant figures will be 0.394. The probability that a score is between 100 and 120 is 0.394. Now, that's a probability of a person chosen at random. So that means the percentage of tipsters who scored between that would be this times 100, to change this decimal to a percentage, 39.4%. And the last part of the question, say there were 1,500 in the competition, how many tipsters would have scored less than 100? Well, first of all, we have to find the percentage of tipsters who scored less than 100. So we proceed, as we've done, writing down always the mean and the standard deviation, always drawing a diagram. So now our picture shows the mean at 120, marking 100 as we did before, but now it's to the left of 100, less than 100. So we need to use our graphics calculator to find that probability and change it to a percent. So we go back. This time our lower bound, well, the lowest you could get in the competition is 0. We could put in 0 there, but it's a good idea just to put in the lowest number that your calculator can handle, which is negative e to the 99. Always it's the lowest value. The upper value here is 100. Same standard deviation, same mean. So we hit XE and see that the probability is this. Using our calculator, we found the probability of a score is 0.106 to 3 significant figures. That means the percentage of people who scored less than 100 is 10.6 times in your 0.106 by 100. So now we've got to find 10.6% of 1,500. Now the various ways of doing that, the way I like is to think of 10.6 as 10.6 out of 100 or over 100. Of means multiplied. So times by 1,500. If you reach for your calculator and work that out, you'll find the answer is 159. In other words, we'd expect about 159 people would have scored less than 100 in the competition.